For over 150 years, the hot dip galvanizing process has been used to protect raw steel from rust and corrosion. To add even more years of protection, as well as color for architectural design, many manufacturers turn to painting. All kinds of galvanized steel products can be painted to add beauty and extend corrosion protection. In this video, we'll introduce you to the process of preparing galvanized steel products for painting. We'll explain how to examine the galvanized steel surface and determine its condition. We'll then demonstrate various preparation procedures needed to clean and roughen the surface of the galvanized coating to ensure that fresh paint bonds to the surface. Welcome to the American Galvanizers Association presentation of Preparing Hot Dip Galvanized Steel Surfaces for Painting. The hot dip galvanized coating is composed of zinc metal and is formed when molten zinc metallurgically bonds to the iron surface of a steel part. Zinc metal is chemically active and when exposed to the atmosphere attracts oxygen and water vapor to its surface, which forms zinc compounds. The rate of zinc compound formation is determined by a number of variables. These conditions include the amount of time since the galvanized part was removed from the zinc bath, the temperature of the galvanized part, and the humidity in the atmosphere. Preparing hot dip galvanized steel surfaces for painting can be separated into 5 steps. The first step is communication between the fabricator, specifier, painter, and the galvanizer. This step is vital because process details may need to be adjusted before the steel is fabricated or galvanized. The second step is to identify the condition of the galvanized coating. The surface condition of the zinc coating will determine further surface preparation steps. The third step is to clean the zinc coating surface. The cleaning process removes organic materials such as dust, grease, and oil. The fourth step is to profile the surface of the zinc coating. Profiling the surface roughens the zinc coating, which helps paint adhere to the surface. And the fifth step is to apply the paint coating. This may include a primer, an intermediate coat, and/or a top coat. The key to good painting of hot dip galvanized steel is surface preparation. Refer to ASTM D6386 for detailed instruction on the basic processes and materials used in surface preparation to obtain quality paint adhesion on galvanized steel surfaces. It's very important for the fabricator, the specifier, the painter, and the galvanizer to know everyone's intention before beginning the galvanizing process. The fabricator may desire special handling to protect the finished coating. The architect may need to change design details to facilitate the application of paint. And the galvanizer must avoid some of the galvanizing process steps that increase the difficulty of successfully painting steel parts. Chromate passivation and water quenching should be avoided when painting galvanized steel. Many galvanizing facilities perform these steps to make the parts easier to handle or to prevent the formation of wet storage stain. Chromate passivation prevents the formation of excessive zinc compounds, but it also interferes with the paint adhesion and can cause paint peeling. Water quenching can deposit contaminants onto the galvanized surface that can affect paint adhesion. Galvanized parts that will be painted may require extra cleaning steps to remove runs, drips, dross particles, and skimmings. While these coating imperfections will not cause rejection of the galvanized part, they may protrude through the paint coating and produce paint adhesion problems. Therefore, extra grinding and filing will be required to remove drips, dross particles, and other coating imperfections. The second step in the paint preparation process is to determine the condition of the galvanized surface as either newly galvanized, partially weathered, or fully weathered. Newly galvanized steel has been exposed to the atmosphere for no more than 48 hours and has few zinc compounds on the surface. The appearance of the finish can range from bright and shiny to a dull gray. Whether the coating is bright or dull, the key factor in newly galvanized steel is a lack of zinc compounds on the surface. This simplifies the cleaning of the newly galvanized parts. After 48 hours, the zinc surface is in the partially weathered condition. In addition to some organic contaminants such as dirt, dust, oil, and grease, there can be a buildup of zinc compounds on the surface of the zinc. These compounds, mostly zinc oxide and zinc hydroxide, must be removed before painting. Partially weathered galvanized steel is the most common surface condition and is the most difficult to prepare for painting. Partially weathered galvanized steel is present from 2 days after galvanizing to about 1 year after, depending on temperature and humidity conditions. If the galvanized parts are stacked too tightly, or if the humidity is excessive, partially weathered galvanized steel may show signs of wet storage stain. Zinc oxide and zinc hydroxide residue forms on the surface of the coating and appears as a white powder. If partially weathered galvanized steel shows signs of wet storage stain, the stain must be removed before the part can be painted. After a year of exposure, the final surface condition is fully weathered galvanized steel. In this condition, the entire surface is covered with zinc compounds. The main compound on the fully weathered surface is zinc carbonate. This material is not water-soluble and does not wash off the surface. A fully weathered galvanized coating is the easiest surface condition to paint. This condition is present after about 1 year of the galvanized steel being exposed to the atmosphere. Painting of weathered galvanized steel can extend the service life of the corrosion protection system many years. Once the condition of the galvanized surface has been determined, the third preparation step is to clean the surface. There are 3 processes involved in the cleaning of galvanized steel surfaces. The first process is to grind flat any high spots in the zinc coating and remove any coating imperfections. The second is to chemically remove organic materials. And the third cleaning process is to rinse and dry the part. Each of the surface conditions of the zinc coating will require a different combination of these processes. Newly galvanized steel must go through the first process to ensure a flat surface. Partially weathered galvanized steel should go through all 3 cleaning processes, and fully weathered galvanized steel will only need processes 2 and 3. If you're unable to determine the condition of the galvanized surface, assume the surface is partially weathered and proceed with all 3 cleaning steps. The first cleaning process is to remove areas of excess zinc and other coating imperfections. Small bumps or runs that normally are not an issue must be removed if the part is to be painted. Excess areas of zinc are produced when the steel is removed from the bath of molten zinc. As the steel part is lifted out of the bath, zinc drains back into the bath. If it moves too slowly, it will solidify on the surface. This is called a run. Zinc runoff can also solidify as it falls off an exposed edge. This is called a drip. With runs and drips, the zinc coating surface must be smoothed over so the coating imperfections will not protrude from the paint. Another surface condition that must be removed is dross particles. Zinc and iron intermetallic particles float in the zinc bath and can be trapped in the outer zinc layer of the coating. These particles are thicker than the coating and cause bumps or pimples on the surface. These must be removed before painting. If there are too many particles or they cannot be ground flat, the part must be stripped and re-galvanized before painting. Another surface condition that may appear are skimmings or black zinc compounds. As the steel part is removed from the zinc bath, it may pass through a thin layer of zinc oxide atop the molten zinc, and skimmings may adhere to the surface. Runs, drips, dross, and skimmings must be removed before painting. The most common practice is to use a hand grinder that will lightly wear away the excess zinc compounds until the surface is flat and smooth. Hand filing is also used to remove coating imperfections. Since pure zinc is a soft metal, care must be taken to remove the excess zinc compounds and leave the remaining surface flat. You don't want to remove the underlying zinc metal. If the grinding process removes too much zinc, the grinder will produce sparks indicating it's hitting bare steel. When sparks fly, the coating must be repaired before it is to be painted. Zinc coating repair methods are described in specification ASTM A780 and include spray metallizing, zinc solder or repair stick, and zinc-rich paints. Grinding and filing must be completed before the chemical cleaning step so the dust and powder from grinding can be removed. The second cleaning process is to chemically remove all organic contaminants from the coating surface. One method is to use an alkaline solution wash. A mixture of 10 parts water and 1 part alkaline cleaner becomes a mild alkaline solution that can remove all organics from the surface without damaging the galvanized coating. This alkaline solution can be brush applied or used with a power washer. The pressure of the power washer must be held below 1450 psi to ensure the zinc coating is not damaged. Solvent cleaning can also be used to remove organics from the galvanized surface. Solvents are applied to the surface using a clean cloth. The application cloth must be changed often to avoid redepositing the organics back onto the galvanized surface. Another method to remove organic contaminants is with a mild acid solution. A non-hazardous mixture of 10 parts water with 1 part vinegar creates a mild acid solution that can remove organic contaminants. The acid solution will also slightly etch the zinc coating and may leave the surface a dull gray color. The mild acid solution is usually brush applied and should be thoroughly rinsed off with fresh water no later than 2 to 3 minutes after application. The final cleaning process uses fresh water to rinse the surface of all cleaning solutions. When using a mild acid solution, a second freshwater rinse is recommended to remove all traces of the acid cleaner. After the freshwater rinse, the part should be dried before proceeding to the profiling step. The part should be painted within 12 hours. This will avoid any further oxidation of the zinc surface. The fourth step in the preparation of the galvanized surface is to profile the surface to provide an anchor for the paint coatings. Profiling the surface means to roughen all surfaces that are to be painted to promote better paint adhesion. A common method to profile the surface is to sweep or brush blast the part. Sweep blasting is preferred over standard blasting because the zinc metal surface is soft. Sweep blasting is angled onto the surface at 30 to 60 degrees to profile the surface without removing the zinc layer. Standard blasting at a 90-degree angle would remove most of the zinc coating. If the blasting process removes too much zinc, the coating must be repaired as described in ASTM A780. One of the abrasive blast materials used successfully is aluminum magnesium silicate. Particle size should be in the range of 200 to 500 micrometers. Other materials that are used include soft mineral sands with a Mohs hardness of 5 or less, organic media such as corn cobs or walnut shells, or stone materials such as corundum or limestone. Sweep blasting of zinc should not be greater than 40 psi while using these abrasive materials. The substrate should be maintained at a temperature greater than 3 degrees centigrade above the dew point temperature. After sweep blasting, the part will begin the process of zinc oxidation on the surface. Painting within 60 minutes after blasting will minimize the amount of zinc oxide that is formed. The sooner the paint is applied after blasting, the better it will adhere to the galvanized surface. Another method of profiling the galvanized surface is to passivate the surface with a zinc phosphate solution. It can be applied by dipping the galvanized part in a tank of zinc phosphate solution. The zinc phosphate reacts with the zinc metal on the surface to form a layer of passivated zinc compounds. This layer protects the surface from oxidation and gives a rough profile for good paint adherence. The part is then rinsed with fresh water and allowed to dry. Painting the part soon after drying will decrease the formation of potential surface contaminants. The final method of profiling galvanized surfaces is to apply a wash primer. The primer reacts with the zinc surface to form a thin film that is no more than 13 microns thick. The wash primer may be applied using a sprayer and can also be applied by using a brush or roller. After applying the wash primer, the parts should be allowed to air dry. Drying times may vary depending on the particular product, the manufacturer's recommendation, and atmospheric conditions. After the surface of the galvanized part has been cleaned and profiled, the part is ready for the final step, painting. Paint can be applied by brushing or spraying onto the galvanized surface. Please follow the paint manufacturer's recommendations regarding air conditions and application methods. Painting should follow the cleaning and profiling as soon as possible. Some paint systems are not compatible with zinc coatings. Please consult the paint manufacturer for information on paint compatibility with zinc coatings. Remember these 5 steps of preparing and painting your galvanized steel. 1. Communicate with the galvanizer before painting the part so they will avoid post-galvanizing treatments. 2. Determine the condition of the galvanized steel surface as newly galvanized, partially weathered, or fully weathered. 3. Clean the coating surface of organics and surface contaminants. 4. Profile the surface of the galvanized coating to provide a rough anchor for the paint. And 5. Paint the prepared galvanized steel surface. The key to successfully painting hot-dip galvanized steel is surface preparation. If the surface is prepared correctly, painted galvanized steel will look great and last for many years. For any technical questions about painting hot-dip galvanized steel surfaces, contact the American Galvanizers Association. We wish you great success in your painting of galvanized steel.